Okay, dear children, now I hope you have gone through the video that I have sent you. Okay, so how to solve, in that video I have shown you how to solve question number 5a. Okay, now I will be using this to show you how to solve question number 5b, c, okay, and as the number it follows. So you have to write down a list of prime numbers first before you do this. Okay, 2, 3, 5, 7, 11, 13. Okay, make the list up to 13. Okay, so to divide 240, you have to use 2 first. Okay, so now 240 when divided by 2, you get 120. And again, this 120, it can be divided by 2. Okay, and you get the answer as 60. Okay, and again, this 60 can be divided by 2. Okay, how many times? It will be 30 times. Okay, so 30 into 2, you get 60. Okay, you can do it like this also. Okay, you can either divide or multiply, okay, to get your answer. Okay, now uh, 30 can be divided by 2. Okay, okay, and you get the answer 15. Now this 15, it cannot be divided by 2, and then now you will move on to the next prime number, that is 3. Now 3, 5 times it will be 15. Okay, so you get 5. Okay, and this 5, it cannot be divided by 3, so you will use the next prime number, that is 5. Okay, and once you get 1 at the end, which means you have completed this particular portion. Okay, and the next will be to represent 240 as the product of its prime numbers. Okay, so now you can refer to this. Okay, now 2 is repeating itself how many times? 1, 2, 3, 4. So there are two fours. Okay, 1, 2, 3, and 4. Okay, and then we have 3 and then 5. Okay, this is how you will solve question number 5b from exercise 2.1. Okay, now similarly you will solve question number c, okay, and question number d also. Okay, and how to know that which number to use? Okay, have a look at the last number. If the last number is even number, that is the number that can be divided by 2 completely, then start with number 2. Okay, but if the last digit is not even, but if it is odd, then you should try it with 3 first. Okay, try it with 3. Okay, in the rough area you can divide the number, okay, 1, 3, 2, 3 by 3, and if you get perfect answer, if the number is being completely divided, okay, then you can use that particular number. Okay, so here for 1, 3, 2, 3, we can use number 3. Okay, when 1, 3, 2, 3 is divided by 3, you get the answer 441. Again, you can divide this 441 by 3, and how much you get? You get 147. And again, this 147, it can be divided by 3, and you get the answer as 49. And now we know, okay, once we reach this area, we know that 7 can divide this 49. Okay, so 7, when it is divided by, sorry, when 49 is divided by 7, you get the answer as 7. Okay, now 7 7s are 1. Sorry, 7 1 is 7. Okay, so you get the answer 1 at the end, which means you have to stop here. Okay, you have completed this particular section. Okay, and now express 1 3 2 3 as prime factorization. Okay, so 1 2 3, we have 3 threes here. 1, sorry, 1 2 and 3. Okay, so 3 threes we have, 1 2 3, and we have 2 sevens. Okay, I want to repeat one more time that you will not write into 1 at the end, uh, into 1 at the end, because 1 is not a prime number. Okay, and similarly you can divide 9360 with 2. You can start with 2, because at the end you can see the number 0. So if any number, if it possesses 0 at the end, that can be perfectly divided by number 2. Okay, so you start with the least prime number, that is the smallest prime number, 2. Okay, and then you can continue your calculation. Okay, now question number 6 is actually uh, same thing. Okay, it is just like question number 5, but at the end you have to express in the exponential form. Okay, I don't want to discuss how to divide. Okay, I just want to highlight in this particular area, okay, how to express the prime factorization as exponents. Okay, so you can see that 75 is equals to 3 into 5 into 5. So you can now again observe that 3 is repeating itself only for one time. So you will write 3 to the power 1. Okay, into, you give multiplication sign, and now 5 is repeating itself for 2 times. So 5 to the power 2. Okay, now let's move on to the next question, that is 684. Now 684, just like this, 684 equals to 2 into 2 into 3 into 3 into 19. So here 2 is repeating itself for 2 times, 2 to the power 2, and now 3 is repeating for 2 times, that is 3 to the power 2, and 19 is repeating only for one time, so you will write 19 to the power 1. Okay, same thing with 1600 also. Okay, so 1600 equals to, you can see it's a very big number. Okay, so now 2 is repeating itself for 3, 4, 5, and 6. So 2 to the power 6. Okay, you just count how many times that particular number it is repeating itself. Okay, so 2 is repeating for 6 times, so you will write 2 to the power 6, and 5 is repeating itself for 2 times, that is 5 to the power 2. And the last number, 2744. So you can represent it as this, 2 to the power 3, because 2 is repeating itself for 3 times, and again 7 is repeating itself for 3 times. Okay, so this is how you will express any kind of prime factorization as the exponential form. Okay, it's very simple.